This is a new video about restoring trashed amplifiers. I actually had made the video earlier, and the original copy vaporized somehow in my SD card, my memory card. Anyway, got this amplifier from Craigslist very cheaply. Missing an output transformer, missing a speaker, missing some cosmetic pieces. This does not have a ticking tremolo, but some of these do. And the cure for that on the second stage is to shorten the grid wire, which goes to the stage. And I've heat shrunk a little 1.5K resistor grid stopper to the second gain stage. And that helps get rid of any weird parasitic noises you may have or ticking tremolos. It wasn't common in these amps, but once in a while you get one that has it. And usually you find it, unfortunately, after you've been inside the amp and moved some wires around, and now the lead dress has changed. So you want to shorten up the input wire to the tube, and if you really have a problem, you want to put what's called a grid stopper on it. The grid stopper goes right up against the grid of the tube. Last piece of thing we did was re-filtered the entire amp, but instead of using the 40-40-40 setup that Traynor used, I've actually gone 32, 32, 16, 16, which has reduced the filtering considerably, and the whole goal of doing that is to give this amp a more woody vintage tone. Okay, so here's the stock sized output transformer, and this is the replacement. There's a full perspective there. That's maybe a better perspective on the thing. So that's the stock piece. Okay, here's the typical 1000 puff 0.001 bright cap that can be pretty shrill. What I've done is I've actually lifted it out of here and taken a 470K resistor and soldered it on so they're in series. That takes the edge off the top end of the bright cap, but still gives the slight mid-range boost that actually sounds pretty good once you take the edge off. So that's my new favorite setup for that particular spot. Here's the input stage. This is the cathode biasing setup for the first tube, and this was 1800, and I've changed it to 820, which gives a little more gain, and then just put everything back the way it should be. And this was originally a 0.1 cap, which provides way too much bass, and I've now changed it for, in this case, 0.001, which makes for a very bright, I wouldn't say a very bright amp, but more of a super lead tone than a Fender amp tone. The other popular choice, or the one I use most often, is 0.01, so 1 decimal place over, basically giving it an octave more lower mids. Don't change much here at all, but I will show this. This is the tone stack, and these are the 3 caps that dictate the tone controls. In a Fender amp, you would change those caps to different values to get different sounds. In this amp, what you do is you this resistor sets the mid-range. It was 47K stock. It's now 27K. I left this one alone, and for a little more gain, change this one from 47K to 470K. So altogether that shifts the EQ from the bass frequencies to the mid-range, gives a little more push to the amp, makes it a little more fun to play for lead. This part of the amp is called the phase inverter, and originally in this amp, and all the amps I get like this, they have a preset 0.1 cap that sets the presence wide open right here at this 4.7K resistor. I clip it out or lift it out, that's gone. That gives you a more traditional sound, or more flat response than the fizziness when you push the amp hard. I also pull out the 0.1 on the back side of the phase inverter here and replace it with a large size 0.1 like you see in all Marshall amps. That's probably me doing that is probably just superstitious behavior. I can't really hear a difference. And then this is the so-called tail of the phase inverter. In this case it's a 420 resistor, and originally there was a 6.8K. I've changed this to 10K. If you want more headroom, you can go up as high as 15K, even 22K like on a blackface amp, and that'll make the phase inverter less prone to distort, give you a different tone. In this case we've chosen the 10K typical Marshall value, and there's 100K. This is called the feedback resistor coming from the output jack, and that's the presence resistor, and that goes to ground. We should talk about this. This is the power supply. If you're having problems cooking EL84 tubes, you can raise this resistor, which I think was, I can't remember, 47 in some, 420 in others. I've made this 1.5K, and then this was the 22K resistor for the preamp step in the power supply, and I've changed that to 10K to give a little more voltage on the preamp tubes, keep the amp a little cleaner. Filtering wise, I've chosen to use way less filtering than the stock values, and that makes the amp sound a lot more like a vintage Tweed or early Marshall. Okay, the last thing I want to show you here is this grounding situation. I noticed when I was playing this amp that if I turn the bass control on full, I get a buzz type sound happening. And what's going on there, this is the ground for the entire tone network, and if we follow it, it comes over here to this grounding point, which is fine and is done properly and it's properly soldered. However, what you'll notice is this power supply filter cap grounds at that point. So if there's any kind of noise on the chassis, it has an equal, if you set the control a certain way so that the control is completely grounded, what happens is the amplifier now has a ground reference. Oh, look at that, there's actually a loop. I got to show you this. So here's why you get hum. The thing is grounded here, connected, 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 and then grounded at the back. Now this is being a blue wire is obviously something someone did later on after, at one point when the amp was being serviced. And so what happens is your ground signal from these pots is getting hum injected into it from this filter cap, and now the signal, because it's grounded in two spots, starts to modulate at 60 cycles. So the ground, because there are two grounds, there's no ground. And that's the peculiar logic of grounding. If you have two grounds, you have no ground. So the solution in this case is simple. I was actually going to move this wire to here, to the preamp, and get it away from this filter, which would still be a good move. But in this case, the solution is very simple. We simply remove that double ground. So there's the finished amp. That's on 1.